Welcome back to Backspace Academy. In this lesson, I'm going to go through some quite complex theory around elastic load balancing. In the highly available and fault-tolerant architecture hands-on lab that we conducted, you had a good understanding, you would have achieved a good understanding of AWS ELB. And now what I would like to do is just take that a little bit further and give you some more advanced knowledge of ELB that you may need for the associate level exam. So in this lesson, I'm going to go through HTTPS and setting that up, and look at back-end EC2 administration, what you would need to do behind an ELB with your back-end instances. I'll look at configuration of your ELB and the configuration settings that are available to you. I'll look at sticky sessions, and so we did talk a little bit about that in that lab, and so you should have a good understanding of sticky sessions as well and why we use them. I'll talk about proxy protocols, so you won't really know anything about that right now, so you'll need to have an understanding of that. And I'll also look at CloudWatch monitoring of ELB and troubleshooting of your elastic load balancer. So in our hands-on lab on highly available and fault-tolerant architecture, we had that set up using HTTP. We didn't have SSL configured, and that made life a little bit easier for us. So just looking at the diagram on the right here, so we've got someone who's connecting in, who wants to connect in at HTTPS. Now, there's a number of reasons why we would want to do that, and obviously it's more secure, okay? Another reason that people are considering doing it now is it does improve your Google rankings as well. So if you've got a HTTPS, then you are going to rank higher over a site that doesn't on Google. So that's another consideration that why you would want to implement this. And it's becoming best practice. Well, it is best practice to do it. So the way that would work is that you would, or the best way, and the recommended way would be to use the elastic load balancer for that SSL termination. So what would happen is that your client device or application or whatever it is that's connecting in there would connect into the elastic load balancer, and then the elastic load balancer would do the work of SSL termination to transmit that out as HTTP 80. Okay. So that would do all of the decryption of that data coming in, and that would leave your instances behind the load balancer to do what they do best, to do their application, to serve requests back through to the load balancer. And you need to remember too that the elastic load balancing service is an elastic service, and it just makes sense to have that service doing the SSL termination there rather than pushing that onto your instances. So there are two ways which we can do this. In the past there was only one way, and it was a bit of a pain to be blunt, and everyone was screaming out for certificate manager because it had nothing to do with cost. It was just that it was a time-consuming process to set these up when you bought them from wherever. To bring them into AWS and preparing them for your ELB. It took a bit of time. So now we have a service called the AWS Certificate Manager, which is a great service. So that can issue SSL certificates for your elastic load balancer, or it can be for a CloudFront distribution as well. So it's integrated in with AWS, and it's a very, very quick and easy way of doing things. And there's a big added bonus in that the certificates are free. So you don't, in the past you used to have to pay $100 and that came down to $20, but you still have to pay for them elsewhere. So it's a cost saving, and it's pretty handy. Great service. So the way that would work is we would use the ACM, the AWS Certificate Manager console, or we could even use an API or CLI command to request an ACM certificate. And then we could use the Elastic Load Balancer console when we get that ACM certificate, or use an API or CLI command to provision that ACM certificate on our load balancer. Now, the certificates must be in the same region as the load balancer, and the IAM user that is interacting with AWS Certificate Manager needs to have list certificates API permission. So that's a very, very good process and very clean and inexpensive process to use. So obviously the recommended process to use, and it's a very new process that's just come out. The old way of doing it was to get your own certificate, buy it from wherever you would buy it from, GoDaddy or Starfield, or whoever it was, and then you would go through a process of making that available in a format for ELB. So the first thing you would need to do is you would need to install certificate tools, OpenSSL or the Windows equivalent that you would use, that could actually manage the conversion of these certificates to the format that you would need. Then you would create a server certificate, and that would involve generating an RSA private key, and then creating a certificate signing request, a CSR. And then you would have to get that off to your certificate authority to have a certificate signed by that certificate authority. And once that whole process was done, then you could upload that to your Elastic Load Balancer, and then from there you could verify that it was working. So that was the old process, quite difficult. So once that's set up and we have our certificate set up on there, once we have our certificate, we can create a listener. And what the listener does, it will have a load balancer protocol, which will be HTTPS, and a load balancer port, which we've got there as 443, and the instance protocol, which would be HTTP and port 80. And so you would have to set up that listener to enable that SSL termination to occur. So another thing that you need to understand is SSL negotiation. So when a client connects up with your Elastic Load Balancer, so they need to negotiate on which ciphers and protocols, or which cipher and protocol to use in that connection. The ciphers and protocols will be defined in the ELB security policy. And so that ELB security policy will be used by the Elastic Load Balancer to negotiate that SSL connection. And the SSL protocols supported are TLS 1, 2, 1, 1, 1, 0 and SSL 3. But that again depends on which security policy you will be using. So if you're using an old one, it may not have all of that available. Another thing that you will need to understand is server order preference. And that enforces cipher ordering, and the load balancer selects the first cipher in its list, that is in the client's list of ciphers. So what does that mean? So when, just looking at our diagram there on the right, so when our client connects into our Elastic Load Balancer, that client will have a list of ciphers that it can actually handle in its connection. And then our Elastic Load Balancer, it will have its list of ciphers that it can handle. So when server order preference is enforced, when it's enabled, the Elastic Load Balancer will look at the list of the client, and it will select the first cipher in the list that is at the top of, or the highest position of, the load balancer's list. So the Elastic Load Balancer will have its list of ciphers. They will be in order of preference. So the load balancer will select from its list the highest on its order of preference list. It will select the highest cipher that is on the client's list. And that's what we mean by server order preference. So the ciphers are ordered on its list in order of preference, and it will select the highest preference cipher on its list that is also on the client's list. And it might be on the bottom of the client's list, but it doesn't matter. That's what it will select. So you should always use the latest predefined security policy. And if you look at the ELB manual or the ELB documentation, you will see that there is a table there of the security policies available and what they support and the protocols they support. And one thing to consider is that server order preference is not supported on the old 2011-08 security policy. So another reason to use a later security policy. So with our back-end EC2 instances, we still need to have administration of those. The elastic load balancer doesn't do everything for us. We still need to administer those or do administration on those to a certain extent. So we have health checks on those. So they are going to be in service if they're healthy, or they're going to be out of service if they are unhealthy. Now the ELB will resume routing to an unhealthy instance when it has been restored to a healthy state. Now the default health check configuration is available, so when you first set it, that will be already done for you, or you can create a custom one. And what is available for you to change will be the ping, be it the protocol port and path for that, the response timeout, so the time period from which it doesn't get a response and it goes into out of service, the health check interval, so the interval between health checks, and the unhealthy to healthy threshold. So that means the consecutive of failed or passed health checks. So if we have just one failed health check, then that's okay. If we have consecutive failed health checks going to the threshold, then that will be marked as unhealthy. So the ELB health check can also be used with an auto scaling group, so as well as the default auto scaling check. So there's some of the things you need to consider for EC2 on your back end behind an elastic load balancer. So another thing we need to look at is the ELB security group. So EC2 Classic, okay, outside of a VPP, the old AWS accounts will have EC2 Classic available to them. Not many people are using it now, but some are. So that will use a fixed security group, which ensures that back-end instances will receive traffic only from the elastic load balancer. So that's a fixed security group. So the other security group, which is the one you would most probably be using, and you certainly should make sure that you use, is the EC2 VPC security group, and that will be created by you. That's not automatically created for your ELB. So what that would look like is, and I'm not going to go into how a security group that works. You've already gone through your lab. You know how a security group works. So we've got an inbound source of everything for 443. So all inbound traffic on the load balancer listener port. So inbound on 443, we allow that. And then we've got on our outbound. So we allow outbound traffic to our back-end instances on that instance listener port, which is port 80. And we also allow it back to our health check book. And so that I've got down there as 80, but it could be any port that you select for your pings or whatever you're using for a health check. So we also have configuration settings that we need to take into consideration for our elastic load balancer. So we have there idle connection timeout. So what that means is if no data is received within the idle connection timeout period, the elastic load balancer will close that connection. So the default is 60 seconds. So if no data is received, it will close that connection. There is also a keep alive timeout option, and that is recommended for listeners, and that is recommended greater than 60 seconds. So you have your idle connection timeout, and you also have your keep alive timeout option for your listeners. Another thing to consider is connection draining. So what that will do is it will keep existing connections open when they are being deregistering, or when they are deregistering, or when they are marked as unhealthy instances. So when something is deregistering or it's marked as an unhealthy instance, the elastic load balancer won't just immediately close that connection. It will keep it open for a period of time. So The reason for doing that is that it enables the ELB to complete in-flight requests. And then while that's occurring, the ELB will state, it will report, in service, instance deregistration currently in progress. Now that timeout period for that to occur can be anywhere between 1 and 3600 seconds. So it's just an opportunity to give those instances to respond if they can respond. Otherwise, it will then close that connection. So after all of the in-flight requests have been completed, or that timeout period has occurred, the ELB state changes to out of service, instant is not currently registered with the load balancer. Another thing to consider is cross-zone load balancing. So if you've got your elastic load balancer spanning multiple availability zones, which is certainly recommended, and having your instances in different availability zones, by default, all requests will be distributed evenly across the availability zones. So what that means is that when we have requests coming in, they will go through whichever nodes are in that ELB, in that availability zone, and then go through to instances in that availability zones. So an elastic load balancer is an elastic service, and it will have nodes which will serve that traffic and then forward that traffic on to the appropriate instance. So we will have nodes in when we look here, if we've got cross-zone load balancing disabled, which we've got there on the left, we would have traffic coming in. We have zones in both of those availability zones, and the traffic goes in. We've got two streams of traffic there coming in, and we'll go to those instances in there. So you can see quite quickly that it's actually unbalanced, and it's less than ideal. So cross-zone load balancing determines how the load balancer selects an instance. And so when enabled, the elastic load balancer node selects the instance regardless of availability zone. So it will select the best instances available, whether or not it's in the same availability zone. So when we have a situation where one availability zone is loaded up more than another, then that node will forward that traffic on to instances, or an instance in another availability zone. So you can see there on the right, when it's enabled, we can see the instances are getting the balance quite correctly, even though the incoming traffic is skewed towards availability zone B. So cross-zone load balancing, something to consider, definitely in your configuration settings. Another thing to consider is proxy protocol. So that is quite important with modern web applications, and it's also something that you should implement when you're using SSL termination on your elastic load balancer. So what proxy protocol is, that it's used to carry connection information about the source, from the source to the destination. And the reason that's important, so if you've got a modern application that's using WebSockets, and so a lot of chat applications use WebSockets, so they get information from one connection to the other, and they need to know where these connections are coming from. So if we have a client that connects into a load balancer, the header that's coming from, or on that load balancer going out to our instances, the header will contain the IP address of the load balancer instead of the originating client. So those instances that are behind the load balancer, they will think that request is coming from the load balancer. They won't think that request is coming from the client application that is in front of the load balancer. So what proxy protocol will do is it will add a human readable header to that request header with the connection information of that client. So that will be the source IP address, the destination IP address, and port numbers. So that way, when the instance receives that request, that instance is going to know that request came from a client in front of the load balancer, not the actual load balancer itself. So the proxy protocol line, it's a single line that is added to the header, and that will then include the client IP and client port. So that's what it will look like. Now, one thing to consider here is that back-end instances, they need to be able to process proxy protocols. So if you've got an Apache server behind that Elastic Load Balancer, it may not process that proxy protocol, so it may not work. If you've got a modern Nginx server, then that would be different. So that would be able to handle that proxy protocol. So these are things that you need to take into consideration for an associate level course. You don't need to be an expert in this stuff, but you certainly need to understand how it works and how a proxy protocol line looks like, and why is it added to a header, and in what situations would you use it. So the other thing we can look at is ELB sticky sessions. Now, we already know about those because we've done our highly available and fault-tolerant architecture lab. So they will be implemented to enable the load balancer to bind a user session to a specific instance. So if we change if the Elastic Load Balancer changes our instance on us, our client application is not going to get in a problem there. So it'll enable us to stick our session to a particular instance. Now, if that instance becomes unhealthy and for whatever reason is unable to respond to requests, the stickiness will move to another healthy instance. So it's not permanently stuck to an unhealthy instance. It will just be moved to another healthy instance, and it will stick to that new healthy instance. We have two types of ELB sticky sessions, duration-based and application-controlled. So duration-based is really where the ELB handles everything. So the ELB will create a cookie, and it's named AWS ELB. And that cookie is used to map the session to the instance. So the ELB manages that. If no cookie is present, the instance will, with least load, will be used. So when you first connect up, there's not going to be any cookie present. So the Elastic Load Balancer will just forward that request on to the instance with least load, but it will then create its cookie, which will then, from subsequent requests, use to map that client session to that particular instance. So the other type of sticky session is an application controlled sticky session. So that is where the application on the instance will generate a cookie with its response back to the Elastic Load Balancer. And then on the basis of that, the Elastic Load Balancer will insert a stickiness cookie. And so the application controls that cookie, and it will remove that cookie when it doesn't need stickiness anymore. And so the application does not, so if the application does not generate a cookie, then the session is not stuck as such. So let's see a little bit more about sticky sessions. So it's not just one type. And there are a number of ways that we can monitor our Elastic Load Balancer. So we have CloudWatch metrics, obviously. So they are measured and sent by the ELB every 60 seconds. So that is at the enhanced monitoring level every 60 seconds. It's not at every 5 minutes, so that's something to consider or something to remember. So that can be the healthy host count. It can be the unhealthy host count. It can be the request count or latency, the surge queue length, spillover count, HTTP code errors, back-end connection errors. So obviously healthy host count, we know what that is. So obviously how many healthy and how many are unhealthy. The request count, so that means basically the rate of requests over a period of time. And latency, obviously we know that has been the delay of response. And then we look at surge queue length. So that is the amount of requests that are piling up in the Elastic Load Balancer or behind the Elastic Load Balancer. So that has a queue, but it is not a infinite queue. So it does come to a certain period where requests spill over and they cannot be handled. So we have a surge queue length, and we also have a spillover count, metric there. And of course, our code errors and our back-end connection errors. So there are the CloudWatch metrics that are available to for us to graph or do whatever we want with. We also have access logs. So ELB publishes a log file for each load balancer node when it's enabled. So that can be anywhere from 5 to 60-minute intervals for doing those logs, and they are saved to Amazon S3 as well. The other thing that we can look at is using CloudTrail to log API calls on our Elastic Load Balancer, which is a great thing if you've got a lot of people that are administering the infrastructure on AWS, and might be a good thing to consider logging any API calls to your Elastic Load Balancer as well as any other resources that you have on AWS. So ELB monitoring, again, it's very, like any monitoring, it's very much an essential part of a SysOps administrator's role. And we have a number of things that we can troubleshoot with an Elastic Load Balancer. So I'm not going to detail all of them and go through all of them, because I would just be regurgitating what comes out of the developer's guide. So if you are going for the SysOps Administrators course, or you're going to sit the SysOps Administrators exam, you really need to know troubleshooting of your load balance to a certain extent. So make sure that you read and understand the troubleshooting steps detailed in the chapter, Troubleshoot Your Elastic Load Balancer, in the ELB Developer Guide. And that will go through the API errors, HTTP errors, response code metrics, health check errors, and instance registration errors, or troubleshooting of instance registration. So again, SysOps administrators need to make sure that you understand how to troubleshoot your Elastic Load Balancer, and the best way to do that is to read the chapter at the end of the ELB Developer Guide. So that's all I'm going to talk about now on ELB. We've covered a very large amount of information there. Hopefully it's retained. If not, go back and redo it again, because you will certainly have some of that on your AWS exam. So I'll see you in the next lesson.